Okay, in our 5.6, our microprogram control, we will cover several parts, which is quite longer. If on 5.5 is only short subtopic only, and we already looked into several others in the video I provided. So over here, you're going to learn on hardwired and also microprocessor. So you're going to go deeper and deeper. Last time you just learned if you have CPU, you only have ALU. And then you're going to have your CU, which is control unit, and also your register. So this is only three main elements normally use check in. But then you're going to go deeper, deeper and deeper. So in this module 5, you are looking in your, mostly in your CU, which is control unit, and also you're going to learn every single detail in your CPU, which is central process unit. You're going to go and learn about your processor. Of course, this is one of your processor. You're going to learn on your register, on the instruction cycle, what basically happened when you have instruction pipeline, and also your control unit. Now we're going to go deeper inside our control unit. So the term of microprogram is an approach to your CU to organize, to design that was organized systematically and avoid the complexity of your hardwired implementation. What is hardwired? What is your microprogram? So same, or I think it's quite easy for me to justify it as hard copy. You need to submit your lab in hard copy. You need to submit your lab in terms of your soft copy. So soft copy is more like writing, and then you will save in terms of file, in your computer and so on file. But your hard copy is something that you need to print out, which is something that you see it for real. Same goes to your hardwiring and also microprogram. This is more into the file programming, while hardwire is something that you can see it like digital logic, which is your gate and so on. So you can see that you have two different categories. One is hardwired implementation. Second is your microprogram implementation for your technique in your CU, control unit. Later on, you will see, okay, this one is your sequential circuit. If you already learned on digital logic, you know, okay, I know this one, no need to mention, because this one is sequential circuit. You know all the gates inside and so on. So hardwired implementation is more on sequential circuit. The control logic is implements, which is the gates, the flip-flop, the decoder, and then other digital circuit. So they will be having pros and cons. Everything inside this world, there is also pros and cons. The advantages of the hardwired is fast operation, because it is small. It is very small. If you know the electronic thing is small, which is require less component. But whenever, let's say, you need to put, okay, this is your calculator, let's say. This is calculator. You need to add a comparator. Maybe you want to compare if A less than B. So you want to compare, you just want to add another function inside. But just because you want to add another function, you need wire change. You need to change all your connection. You need to modify your design. And for your microprogram, the advantages is systematic and require change can be done by updating your microprogram in your control memory. Of course, when you have like in terms of line by line, maybe you want to change some of part of this, which is you want to make put a comparator. It's quite easy rather than you need to put something a comparator inside the sequential circuit. And on top of it also, you have disadvantages, which is slow operation, requires more components. This is a new words for those who did not watch the video I uploaded into your e-learning. This is your new words. You don't know what is micro operation. The control information is stored in your control memory. Okay, if you have one single instruction. Okay, you have a single instruction. I give you example, maybe you have move EAX 1000H, and then after that you have add EAX. This one is just a name which is already assigned there. Okay, this one is the example. So this one single instruction, this is one single instruction. To process one single instruction in your Visual Studio is very easy. You just need to press the F11, or maybe you just press the debug. Everything was end. Everything will be finished, and suddenly you will get your output. Easy, right? But basically, you need to know what is happening when you have all these following instruction. Let's say you have 10 lines. So you will step by step debug it. Step and then step another one. And every step, when you already done this step for this single instruction, you need to know in behind you have something doing, which is step by step. So last time, if you look into the video, you have learned one single instruction have their own one cycle. So how long the one cycle is, which is including the fetch. After fetch, you can also have fetch, execute. And then after that, you can have interrupt. And over here, sometime after you are having fetch, you have the indirect. Okay, when you read your line, move EAX 100 hexadecimal. When you read, what fetch will do? Fetch will do fetch the instruction and then do the decode, and maybe it will directly go to the execute after it's done the decode. But sometimes there is an operand that enable your indirect operand. You need to do this, and until that you will follow back to execute. And whenever you execute, maybe there is also a interrupt happen. Then you follow by until you finish all your 10 lines. So this one you already learned in previous video. And what is micro operation? Okay, your program, which is your source code, when you run, is called as a program. But inside it, you have several instructions. So it called as instruction. So inside instruction, what happened? You're going to do your fetch, you're going to do your execute, you're going to do your interrupt, you're going to do your indirect. So this one is your single instruction, and it's called as operation. This one is operation of fetch, this one is operation of single instruction. And on top of fetch, execute, and so on, it's basically having step by step. This fetch having some of, maybe before you're going to do your fetch directly finish, you're going to fetch and then you execute, encode, and you're going to do something over here. These all tasks, similar also execute. What is basically execute doing? So all of these tasks in those operation is called as micro operation. So now you already know what is micro operation. You can always refer back to my video and check back what is basically micro operation. And you need to know also what is the task and what is the step by step for fetch operation, execute operation, indirect operation, and also interrupt operation. Okay, this one you can see it's slow operation, require more component for your microprogram. If you see, you can just blink your eyes and you get the result. But it is slow compared to your hardwired. Although you cannot see it because it is maybe in a microsecond, or maybe in a microsecond, or maybe in a nanosecond. It's very fast because it's a system. After you know all this, you're going to go deeper and deeper, which is you're going to learn on micro operation. This one is, I already show you what is micro operation. To implement a CU as an interconnect of basis element is not an easy task. So you're going to see there is a problem. That will be a problem for you to implement a hardwire, which is difficult to design and test for hardware. Design is relatively inflexible. So all of this is very hard. So this is the disadvantages of hardwire implementation. That is why these micro operations or your microprocess, microprogramming is the solver. It is a solution for you or an alternative to a hardwired control unit is a microprogram control unit. And you can also call it as microprogram or firmware. The microprogram consists of sequence of instruction which is micro-operation. This one, all this step by step over here is your micro-operation. If you combine it together, it's called as microprogram. A microprogram control unit is a relatively simple logic circuit which is first sequencing through micro-operation and generating control signal to execute each micro-operation. Okay, this one. You can see you maybe was thinking, how can we use this microprogram to implement its control unit? Because you know about microprogram is a solution, but how are you going to apply it? Consider for each micro operation, the CU is allowed to generate a set of control signal. So the one, each of your micro operations, CU will allow to generate a set of control signal. How CU generate? So CU, from CU, you're going to set a signal, whether it is a on or off. In digital logic, you already learned 1 is normally high or on, 0 is a low or off. So where you want to implement it? This is the example. You have your control unit. Your control unit will send 1, 0 signal to your micro operation. So this is your micro operation, right? You microprogram. In your microprogram, there is a micro operation 1, 2, 3, and etc. So let's say this one is positive, adding process. This one is minus process. This one is multiplication, and also lastly is your division. So when your control unit instruct you with the value, it send 101 or 1001. So it send to your micro operation. So when you send it from your control unit, you will notice that each of these code, you have several other codes. There is a lot of code that you can use. It's going to instruct a micro operation inside. Maybe if you have 1001, you're going to enable the adding and also your division process. While if let's say you were sending from your control unit the value of 0110, then you will get the operation for divide, subtracting, and also your multiplication. So this is just example in your fetch instruction why and how your control unit will be given the instruction. So where is your control memory? Your control memory is inside your control unit. See, you go deeper and deeper. Last time you have CPU, you are looking into your ALU, you are looking also at your register, and then you see your CU. But now you look deeper in your CU, control unit. In your control unit, you have your control memory. After that, you're going to see what is the input. What is the input? What is the output for your control unit? So over here, let's say you have routing one, maybe you have a fetch, and then you have execute, and also maybe this one is interrupt. And maybe you have an operation adding, multiplication, subtracting, and etc. So, mana dia punya? Wait, I show you first this, then you can compare. So this figure, it is your control unit. So you can see this one is your control memory, the one that you see inside this picture. So inside this control memory are having all these routing. What is the cycle available? But on top of it, at outside, what is having connection is from your control unit. You can see you have a connection to your control buffer, to your control address, and etc. Later on, we will see. You're going to go deeper and deeper. Then you can see, control unit, there is a lot of element. I thought it's only one, which is control unit. I thought it's maybe only control memory. But then you can see a lot of other element that you need to see inside your control unit. Last time you will see that you just learn that control unit will control a movement of your data, and the task is very simple for you to remember. But now it's going to be bigger and bigger when you are going to be deeper. Now you can see over here you have a MicroProgram control unit. The set of micro operation is stored in your control memory. So this is the one, the control memory you see in this picture. But at outside, you have a connection. You're going to connect your control memory with the sequential logic, control address, and also control buffer. What happened is the control address register content of the address of the next operation. So first of all, the flow will be like this. Later on, you will see the flow, which is sequence logic will be instruct the read to your control memory, and then control memory will generate the control buffer, and then it will flow looping. When micro operation is read from control memory, it is transferred to your control buffer register. Figure show the program routing could be arranged in the control memory. So you can see over here you have fetch, you have indirect, interrupt, execute. And then there is several others that a cycle that you might also available in your control unit. And you can see the micro operation in each routing are to be executed sequentially. This is the important keyword, because you can see in fetch, if you have routing 1, routing 2, routing 3, and etc., you need to do it sequentially. After finish this one, then you can continue with 2. After finish 2, then you continue 1. You cannot jump from 1, then you go to 3. Or maybe from 3, you go to 5. You cannot do in the micro operation. But if you can see over here, if routing, fetch, indirect, and interrupt, it can jump to another. It's not going to be sequence like this. So you can instruct it to jump to any specific program, but of course it's going to follow the instruction, not just like fetch and then execute. So you can go to here, and also maybe there is indirect, and then you have interrupt. You cannot directly go to interrupt from fetch. You can only direct go from fetch to indirect or execute. From indirect, you can only go to execute. You cannot go back to fetch. You cannot go to the interrupt. For the interrupt, you can go to fetch. See? So this is the each routine. Before you end, you're going to have a branch or a jump instruction. Where you want to go next, where you're going to go, whether it's go to specific, next, and so on. So over here, you can see you go deeper. Before this, you're going to see only this one. You only see this part. If you compare this figure with the previous picture, not this picture, this one. This figure, if you compare to here, it is on inside this. Okay, then you can see, we see the control unit still has the same input, which is, okay, you notice later on, you're going to have several input and then several output for your CU. Control unit, there is a list of input. Control unit also have a list of output. This one in your previous subtopic. What is input that have, which is your IR, and then you can see also over here your ALU flag. This is your IR, instruction register, and another one is your clock. So all of this is input for your control unit. And you also have the output, which is the control signal, but it can divide it into two, which is the within the CPU or in the system bus. Your control signal in your system bus or within the CPU. So this is the only output, and this is the 3 inputs for your control unit. So now, you can see over here what is happen if you have MOV EAX 100 hexadecimal. This is single instruction. When you press execute, the sequential logic unit, this is what happened first inside. You did not see it in your Visual Studio. You cannot see it while you are running the programming. But basically it's happened. Your sequential logic will issue a read command to your control memory. So this is the first things that will happen when you execute this single instruction. Then the word whose address is specified in the control address is read into the control buffer register. So you will see, let's say, I give you example, your initial value is 4,000. So you will read this address first and will be putting into your control buffer register. And after that, the control buffer register, this one, will generate control signal and next. This one is important because the first initial value is, let's say, 4,000. And when it's generated, the output will be 0001. The next address information for sequential logic. So it will send it, the new address, to your sequential logic. So it's going to be like a loop again. So that is number 3, what has happened. And the last, the sequential logic, this sequential logic, load a new address. You're going to load the, let's say, 4001. And it's not going to be the next address, but you're going to see on the next address from the control buffer. This is the control buffer you were given with this value, and also your ALU flag over here. So there is input. Let's say your ALU flag is 1. So what is happen when you have this and this? Your control, your sequential logic will decide it what is the next address and send to your control address register. All these happen during one clock pulse. So you cannot see it one clock pulse. Maybe it is a nanosecond. Okay. So you can see at your last step, which is step number 4, the last step is listed needed an elaboration, which is you need to have the next address from your control buffer register, and you're going to combine it with your ALU flag. Okay, over here you're going to see that the last step just need elaborate on what is happening here. Next, address decision. How your sequential logic will do an decision for the next address from the control buffer that coming in, and also the ALU flag. So first, depending on the value of ALU flag and the control buffer register, one of 3 decisions is made. So you're going to decide with these 3 decisions. First, get the next instruction, which is add 1 to the control address register. to jump to a new routine based on the jump micro operation, which is you're going to load address field of the control buffer register into your control address register. And three, jump to a machine instruction routine, which is load the control address register based on the opcode in your IR. So there is three way for you, not for you, for sequential logic to decide the next address. This one is on your address generation. So there is two way, whether it is explicit or implicit. You're going to see what is list on your two fields, explicit, and what is listed implicit. Under explicit is going to be generate techniques that having to fill conditional branch and conditional branch, and implicit mapping, additions and control. What is the purpose? The address is explicitly available in the micro instruction, and while for implicitly it is require additional logic to generate the address. You're going to see what is the meaning of mapping, because normally mapping will be the mapping is one of several implicit techniques that commonly used. So you're going to see commonly that you are going to use the mapping. What is mapping? Mapping will transform from instruction code, the one that you type coding, which is instruction code bits, your opcode. Let's say add, you have the instruction code. Let's say I give you this one is the opcode in bit for additional. Move, let's say the code is 0101. Divide, maybe there is another opcode. So this is the mapping. Mapping transform from instruction code to an address in control memory where the routing micro operation is located. How are you going to see it? This is the one. Let's say I give you okay. So this is the opcode instruction. This is the opcode instruction. You can see for add is going to be 0000. For AND, this one is AND process 0001 and etc. So this one is just example. Just for you to know what is opcode or opcodes of your instruction. Okay, go back to this slide. So you can see that you normally will use your mapping. So phase cycle routing, this one, okay, you have adding lah. Add EAX 10. So this is your opcode. This is your operand. This is one single instruction. And in all of this, if you know, you're going to have several cycles. Fetch cycle, indirect cycle. You're going to also have your education and etc. So in your opcode, you're going to have the routing of whether it is additional or subtraction, depend on your codes here inside your control memory. So depend on your opcode, what is your opcode that are using on this. operation. If adding, what operation and what opcode. If subtracting, what opcode, and etc. So mapping of instruction. Wait, someone call. Okay, under your mapping instruction, a special type of branch exists when micro instructions specify a branch to MicroProgram route for an instruction is located. There are two methods basically on your mapping. First is direct mapping. Second is using your ROM to specify mapping function. This one is very easy because it's directly will be applied into your next addressing. So let's take a look how it's going to be applied into these two methods for your mapping instruction. How you're going to instruct and decide for your sequential logic and how you're going to apply it into your ALU and also the next address that will be decided on your control buffer register, because you're going to use it as the next address. Okay, so there are two. So first of all, we're going to look into direct mapping. Under direct mapping, you can see the status bit for the type of branch are the bits in the operating code part. So this one, instruction. So computer instruction, you have the opcode. This one is opcode. Let's say this one is move. And then of course you're going to address, having an address or operand, it depends. But this opcode, your operation code, in terms of bit code, you're going to have this one, 1011 for move, example. Then this one, you have the mapping bits already given. What you need to do is you just apply it back to your micro instruction address, but of course you need to put the mapping bit also. So on XXXX here, you're going to replace directly from your opcode. That's why it's called as direct mapping. So this is direct mapping from instruction code to micro instruction address. Another example, you can see over here, you have the mapping bits already given. And this is your opcode. Your computer instruction 1011. So what you need to do is you will bring down back your mapping bits and directly using a direct mapping, you're going to apply this opcode inside your micro construction address, and this is your final answer for your next address. So it's going to be quite easy because you just directly apply it. And example number 22. Mapping from instruction code to micro instruction address. You can see over here if the opcode bit is 1001, then you just apply it, which is a direct mapping.
It's 16 hours.
That's why I already shows you what happened. On the opcodes, you can see there is a specific codes for add will be 000, and will be 001, and there is a lot other that is already mapping as the direct. So you can see over here, you will just apply it on top of your address. This is your direct mapping, how the way you're going to apply it. Another one, another technique, you're going to have what? Using ROM to specify mapping function. One can extend the concept of direct mapping with more general rules by using ROM to specify the mapping function, address of the mapping ROM. Okay, one can extend the concept of direct mapping with more general rules by using the ROM to specify the mapping function. So another one is the bits of instruction specify the address and mapping ROM. So you're going to see over here, if you have direct mapping, you're going to apply it directly, right, to your to your micro instruction address. But you can see over here what is the difference. You can see over here, you have ROM. So this code, similar to previous example, which is direct, similar opcode, you will apply it directly, but using the ROM, you're going to send it to ROM first, and from the ROM, it will send to your control address register, and after that to your control memory. So this is the flow for another methods under ROM specify mapping function. So you can see over here, the microprogram routine can be anywhere in your control memory. Which is what is the advantages? It provide flexibility for adding instruction for your control memory as arise. So the difference only that if it direct, you can directly apply it, but for using a ROM, you're going to send to the ROM first just to mapping it after it. So that is on the mapping process. How you going to generate the address? Not you are the one, but your system, sequential logic, will generate. Because if you see over here, you're going to have two input from a ALU flag and also your next address control. So that's why for the actual next address, you need to define it first. What is this by having these two different input. So you have two kind of methods, which is mapping and also another under mapping you have two method, which is direct mapping and also using ROM specified mapping function. Okay, next we have another subtopic. We have about another 20 more slides to go until we finish. Going to finish it first, and I guess after we finish with test 2 discussion, we can do all the examples together. So you can see under micro instruction format, we have two main categories. horizontal micro instruction, and also vertical micro instruction. What of these two formats? Each micro instruction specify many different micro operation to be performed in parallelly. So this one, if you are using a format of horizontal micro instruction, you're going to perform it in parallel. While for virtual micro instruction, each micro instruction specify single. So this is another keyword for you to see, which is this is many different and this one is single, or maybe only few, maybe one or two only micro operation to be performed. Because it is many over here at your horizontal micro instruction, of course you can perform it the task together parallelly and synchronously. So over here you can see this is typical micro instruction format. You have the horizontal micro instruction and you have the vertical micro instruction. How it's going to be look like? Let's say this header, this block is micro instruction address. You can see over here this is micro instruction address, and you have another one is jump condition, which is this unconditional zero overflow indirect bit. So you need to remember the template. What is this header for? It is for internal CPU. What is this block for? It is a system bus control and etc. And this format is only for horizontal micro instruction, while for virtual micro instruction there is a different format. So each of these format having the different of box here. So please make sure you remember how it's look like. Computer hardware configuration. So you can see over here, this is your computer hardware configuration. You have a lot. Sometimes you still did not understand it's like a marks. But this one is you already learned in your digital logic, mark, demarks, and so on. So you can see you have marks, you have AR, PC. This one you already learned in your previous subtopic. And then you have your memory and marks again. So all of this is a connection to each other. We have DR, arithmetic logic, and etc. This one is just for example for you. As long as you understand that they having a connection to each other and how the computer hardware are connected on the flow. So sample of 4 computer instruction. This is the normal instruction that you see. You have the opcode, you have also the address. This is the instruction format, normal instruction format. I is indirect addressing, which is you need to specify the address. And over here they are already specific you with the how many bits that available. So all together in one instruction format you have 16 bit, isn't it? So for your address you allocate as 11 bits. For your opcode, you have 4 bits, and lastly you have 1 bit for your indirect addressing. So altogether it is 16 bit. So 4 digit of your 4 bits for your opcode can have 16 possible instruction. Okay, so this is the instruction format, and you can see also there are 4 sample of your computer instruction. As I already mentioned, each of it have their own opcode. So let's say a symbol of add is 0, 0, 0, 0. A symbol of branch is going to be your opcode of 0, 0, 0, 1. So this one is depend on your instructions in your source code. So what will be your opcode? And this is the description for your operation. Under micro instruction format, this one you can see it's quite different with your instruction format, because this one is the micro instruction. So how many? You can see you have F1, F2, F3, which is a micro operation field. 3 plus 3 plus 3. You already occupied 9. And then condition for branching, CD. How many you have? This one is 11, 12, 13, 20. And then you have a branch field as a 2 bits and addressing of address field. It is 7 bit. I need to check back. Is it 7? So this one is a micro instruction format. How you're going to see what is element inside. So what is element inside of each box header? Virtual micro instruction format. Okay, so now you can see there is a specific on the F1, F2, F3. So you can see the field description for F1, F2, and F3. For F1, 0, 0, 0, it means that none or a symbol is not. 0, 0, 0, 1 is going to be add. Because you can see over here, it is occur 3 bits. That's why you have a possibility of 3 to the power of, to the power of 3 is equal to 8. 1, 2, 3, 4, 5, 6, 7, 8, 8 possibility at operation for your F1. For your F2 also 3, F3 also 3 bits. So you can see all these value that available. So you need to see what is basically happen in the operation as well. And the micro instruction field description, you can see CD or BR. The conditions for branching, you have CD 00, okay. What happened is, you can see over here, you have CD which is 2 bit. So your possibility is to the power of 2 equal to 4 possibility of operation. 1, 2, 3, 4. You have 0, 0, 0, 0, 1, 1, 0, and 1, 1. Same goes to your BR. So this listed all the symbol and also the conditions that happen in your CR, CD, and BR. So you need to go through one by one from your F1, F2, F3, and then CD, BR, and lastly your AD. AD is 7-bit. Is it 7-bit? Let's take a look. Oh, it's not mentioned here. So this one is already fixed. And AD is address field. So it is already mentioned over here, 7. Okay, let's take a look first the example. Let me check. Okay, this one, this example, there is two examples, example 23 and example 24. So we're going to see the solution in a specific video, which is only that video I will explain to you, and we're going to discuss in our next class after we already cover our test 2. I don't want you to like having too much, then it's going to be confused, especially for those who still not yet finish watch all the video that I provided in the e-learning. Okay, so we're going to skip for example 23 and also example 24. Now, after you've been through all under your control unit, what you need to see is you're going to do a conclusion. Of course, the conclusion is what is the advantages and what is the advantages of your microprogramming. So now it's listed all, which is the advantages of microprogramming. It is simplest in design, and then it's both cheaper and less error than if you're having the hardware. You need to like doing all the sequential circuit back, and maybe there is a short in your circuit. Also, you need to buy extra circuit and so on. That's why this programming is much cheaper. The decoders and sequencing logic unit are very simple pieces of your logic. But of course, you're going to have the pros, which you're going to have disadvantages. So what is this? The advantages is it will be somewhat slower. This one we already looked into, that our microprogram is much lower if you compare to the hardware. So that is about the advantages and disadvantages of microprogramming. Despite this, microprogramming is the dominant technique for implementing CU in a poor CISC, the complex instruction set computer architecture, due to its ease of implementation. Of course, it's going to be easy for you to erase, to restructure your programming rather than you need to redesign your sequential circuit. So the summary, this one is what you have learned, but throughout, I guess some of you and most of you still did not watch the video that I provided in the e-learning. So I hope you can watch it first, and throughout you can answer all the question, which is review question. If you can answer it, then you have the full understand. So any question related to what we have learned in this 5.6? So if you have no question, please first watch the video in the e-learning from your 5.1. After that, then you will see the flow and you understand what 5.6 are about. Next class, in our next class, I guess we're going to explain on our explain and discuss on our test 2. We're going to do together. Same goes to what happened on our test 1. We're going to do together our past year test 2, and also we're going to do several other example I will provide it later on. Maybe I can also create a mock test 2. Same goes to last time for mock test 1. Is it okay?
Okay.
Okay.
Okay, Doctor.
Okay, please don't forget, you need to submit your lab 2. I think I need to create the link, isn't it, for the submission. I forgot whether I already created or not. So I will do and create the link for your lab submission. And just to remind all of you, please make sure you submit 2 versions of file. One of it is PDF and another one is video of recording. The video recording, you need to insert your voice and your team member. If you have 2 member, you need to have 2 different voice. So it depends whether you want to share your face or not, but you need to have different voice, your friend, your team members. And you need, although it is a group lab, group work, I recommend you to submit individually. As I mentioned last time, the leader of the group forgot to submit until at the end. So it's will affect your team member. So you do it together, but maybe you can submit it individually in your e-learning. But please make sure in your PDF file, write your team member names. Is it okay? So I'm going to create the link, and the due date I give you until this Saturday. Some of your friend is just having finished doing your lab 1. Before that, did I discuss with you the question of lab 2?
I don't think you have.
Oh.
Also the deadline too.
About the folder, the file also I did not give.
You did share in the e-learning, but you didn't discuss or give an overview.
Okay,
Yeah.
okay. We have another 30 minutes. Let me open. Here. This is lab 1. Okay, this is lab 2. I need to open, okay, SCSR. I need to open SCCR. It's okay, I show you first. Later on, I will change the file. Because the file, there is 2 files. If you look into the file, it having like different like organization. Question 1 is different, question 2 is different. So I will recorrect it. Okay. Throughout your lab 2, what you need to do? this one you can see, because your lab 2 is very important, especially for your test 2. Some of the question is coming out from the technique you do in your lab 2. Okay, yeah. This one you can see in your lab 2 what you will cover. You're going to cover and learn the exchange, INC, DEC, and EG, and etc. You will see what is basically this operation mean. So there are several parts, but I hope that this one is the correct version because your words is having different in organization. But it's okay. Basically, the explanation is similar. So you're going to see the operation that you will use is XCHG, which is exchange data. And you need to try to play around with exchange later on. There is a lot of exercise will be listed if you check. And then you're going to see the INC, the increment, the DEC, decrement, NEG, negate, and then MUL, multiplication, DIV, division, and etc. But you can see over here, I already upload extra note, especially for your register. Now you can see you're going to play around with your register also over here. Okay, if AX, BX, how many bits? It's going to occupy 16 bit. AH, AL, it is 8 bit. So if you did not remember, because it is not in your notes, I guess, I give extra notes already in your e-learning. Please find your extra notes, especially for the register, and please learn all the register. EX, 32 byte, BX, AX is 16 byte. And you can see over here, you also will play around with this. There are 16 bit, there are also 32 bits. If you don't know about all these register, you cannot answer it correctly. So please take a look at the extra note that I provided, because mainly in your notes and slide, they are not given. But there are several parts. Part B, Part C, I guess until Part D. So let's see over here, our part B, you need to do a little programming. But basically you just need to copy this. You can see you're going to copy this, and what you need to do is you need to run it to your Visual Studio. I guess I will share you the video I explained to another section later on. Because I also run this coding. So you can see when you run this as in your lab 1, if you still remember in your lab 1, you're going to have the register. Mana saya nak conteng Wait Okay, so over here, let's say you were given with the value of VAR1, words 1. So this is occupied as one word. So what is how many bits? It is 16 bit, it is 32 bit. So please check it back. When you run it, it automatically give you the output. So you will directly get the output, but the output will be showing you the list of register like EAX, EBX. There is no, mana saya tadi? Okay, there is no output specific for AX. There is no output specific for AX. There is no specific for BX, and etc. So over here, how you need to do is, that's why I need to explain. If let's say your output, okay, you will see this is your output terminal. Of course, in the first line is going to be EAX equal to, let's say over here, first this one is maybe the initial value. I just put it F120 and then maybe 0001.
غادي يراولوا شحال دولابي دولابي
So
لا لا مطبلات غادي
this is the example.
ما فيش راهو
And I think you forgot to mute.
لا لا في الدار هذيك يروى
Wait, I mute. Hey, already. Okay.
Doctor, I have a question. In video, what we need to say? I mean, what we need to explain?
Okay, wait. I explain the question first. Okay, over here, your output you're going to get EAX. EAX is 32 bits, isn't it? So your answer will be 16 bit and 16 bit. Over here, MOVAX, you need to move your VAR value, which is 0001, to your AAX. That's why your output in your Visual Studio will be only EAX. And where is your AX? Your AX value is this one. This is your AX value, which is 16 bit. If EAX 32 bit, it's going to be longer like this. So that's why you're going to pick this value and put it here as the answer. And what is the val of the var1? Of course, you're going to modify it by yourself and move the value of VAL, which is into the register. This one, I hope that every I hope that every groups have different explanation. This part you're going to explain. What is this instruction about? So in terms of your own way, how you're going to explain. And var also is available in your output, but throughout, if you just see this, you're going to directly having the output. And after that, you can see you have line 1, line 2 is already specified. You need to find all the value. In your lab 1, you're going to press F11, F11. So every single line, you're going to get the output, and you just fill in the value and explain what is the instructions about. Okay. So you need to fill in. So I just teach you one example question. Basically, I need to show you. Last time I already made the video. I guess I already shared again also. So over here, you're going to see you have question 2. You given also with the program, and you just need to fill in the answer using your output. And then after this, and this one is all that you just apply it, the programming. And this one is part B. Part C. Part C is slightly different in your part B. Over here, you need to find the arithmetic expression. You have move, and then what is over here, add, and so on. You need to find the arithmetic expression for the code that given. If you did not understand, you can just ask me. Section 09 is okay. Only that they are arguing why this PDF and Word version is different. Okay, next is your part C. Your part C, you need to write your answer in the line. If you think that some code below got error, maybe you run. When you run, you're going to see what is the error, right? So you need to find it and explain. Okay, same goes to this one. You need to fill it in with the correct answer. It's not too hard. Now, what you need to submit? You're going to submit 2 file. First, this file, the lab manual file, and this will be look like this. Yeah, it's opening. Quite slow. Okay, it's going to be look like this. But please make sure you put your name and your metric number, but please also add in your team member name. Please add on your team member name inside this. What happened? Why I hear the sound but I didn't receive any question? Mana saya punya words tadi?
Basically, I raise up the hand because I have a question. Actually.
Okay. What?
Actually, the thing is that my teammate is where I don't know. He didn't attend the class regularly. I don't know. Can I rearrange the group or something like that?
Okay.
If others agree.
Okay, like this. Some other section also having that kind of problem, communication problem. So what I suggest is, if let's say you want to change a group, because that I also received some WhatsApp from your friend, they are not having a good experience with the team member. So you need to find some other members. You need to swap. Unless you both agree, you and your team member agree, you want to separate. You want to separate and you want to do alone also can. As long as you submit the file and you need to mention the team member. If you want to do it alone also can. And the video, you need to submit the video explaining on the question. What question? You have several part C, part B, part D. I give you the freedom to pick any part that you think is good for you. You can explain it with the perfect term and condition. So you pick which part that you like, then you explain it. I just want to hear, let's say you have two members. I want to hear two different voice, which is you explain and your friend explain. It depends if you want to show and enable your faces or not. As long as while you explain, you can show it where and which part you are explaining. Not just voice, but the picture is not moving at all. So about the team
Okay, I got it.
okay, so about the team member, I give you flexibility. You can choose, but don't leave your friend, your team member without their knowledge. Then maybe they said, I have team member, but this person did not inform me that he want to left. That will be a problem later on. So you politely tell your friend that you want to do alone, or maybe you want to rejoin to others, but please don't make too many person in one group. Maximum one group is
Uh,
2%. Okay, what?
2% in maximum in one group or more
Uh,
than two?
because you want to join another group which is already 2%. If you join, it's the maximum.
No. Actually, others team member is the same problem. Their teammate is not here. They don't know where. So they are discussing with me. What about you? I say my situation is same. I
What
don't know why
happened?
is my
What
team
happened
member
to all of
even.
you? This you don't meet your friend.
I don't know. Even that day, today, he didn't join the class.
Okay. But because if you already meet, then you need to have like communication skill. That's why you were given with a different person or unknown person.
Actually, if I didn't catch the people, how can I communicate? I didn't find him. Where I find? He didn't join the class. All everything. How can I find? How can I communicate?
Okay. So it is okay. Yeah, I think also now we have 18 students, right? Two missing. Okay, so what any other question that you can ask me? I will give you the due date. The due date is after your test 2. Because what is the priority? Okay, Ines?
Yes, what about me, doctor? You forget my name in the list.
Huh?
You said I should join with Misa, I think.
Again.
You forget my name in the list about lab 2.
Then did I think I already replied whoever said they didn't have group. I said you can join. Where is my phone?
Yeah.
I think you in group 1.
Yeah, with Misa, I think. Who is Misa and Ala?
Yes.
Who is Miza? Hey, you can check. Here, Miza Nabila. She is here. You don't see your friend name?
Doctor, there's also an issue with me. You paired me with someone I've never heard of, and he's not in the class as well.
No name here. Hey, how many students? I think it is nearly to be full, right? Only 2% is missing. And all of you claim that someone is...
I think the 2% is me and Furkan's teammate.
The name is Muhammad Uzair Fahimi bin Muhammad Nordin @ Nor something.
My one is Tobago Shilham.
Uzair dropped out.
Oh,
Uzair, okay, so there you have it. I am alone, so I get to choose.
maybe drop, but because I picked the name is on the Ames, right? So I don't know whether he already dropped or not. So, so about the due date, I will give the due date after your test 2, because what I want you to do and focus more now is your test 2. But again, I mentioned to you, your lab 2 will be also important for your lab 2. For your test 2. For your test 2, when you do your lab 2, you have a skill to answer. That's why I want you to do your lab 2. Although maybe you are not recording it, maybe you will record it after your test 2, but please do it. You run it, maybe you do it alone without discussing with your friend yet. And then you will see how you're going to answer. Then you can answer your test 2. So that's why I ask you to answer the lab 2 first. Then after that, I will give you the due date after your your test 2. Is it okay? So no need to submit first. No need to worry about the submission. No need to do the report. No need to do the video. But you need to do it by yourself for your knowledge. Is it okay?
Doctor,
Okay.
actually for lab 1, I didn't use my voice. Is it okay for video? I just screen record and run it.
Lab 1 is individual, right? So that's why last time I think I already, because last time I already mentioned to all of you what is the purpose and what is the purpose I asked you to do the voice, because maybe you just reuse your friend video. Your friend is doing it, so that's why I cannot define whether it is you're the one that do it. But if let's say you already inform me, okay, then for lab 2 I'm okay. But for next lab, please make sure you use your own voice and your team member.
Sure.
Okay, so any other question? So again, for those who ask me about your test 1, I will only can share what is the wrong. But basically, I hope it is before your test 2. Because you're going to see, maybe you are doing it correctly, but in terms of the problem will be at the e-learning. I don't know, right? That's why I need to see also, and I need to share with all of you. But now I cannot. So I hope that we can discuss it before our test 2. And I hope some of you like getting the high score in test 2 will test 1 will also maintain and improve in your test 2. Is it okay? For those who get low marks, maybe you can double up your study and you can score for this test 2. I hope so. So any other question?
Doctor, isn't it a better option to have tests get marked by lectures instead of e-learning? Because correct answers can get marked wrong.
That one I'm doing also, because I think it is mission, right? I already voiced out, but most of them are rejecting my opinion. So
Can you not check it yourself only for your sections?
Okay, I will do so, especially for test 2, test 1, and your final exam later on. For your marks, okay, yeah. And you can also ask me if, let's say, you think you are doing it correct and maybe your marks is too low, maybe I will check also for you.
Can you recheck test 1 part B for me?
I will check for all after, because I'm going to share it to all of you. So if you want to see it, we're going to open it personally one by one to see how the e-learning check your answer. Is it okay? After the the student, I guess 4 student taking the test 1.
Okay.
Will the final be checked by the e-learning as well?
That's they are planning to do so. But it's not yet confirmed. They're planning to do so like this.
Like there can be part 1 on e-learning and part 2, on pen and paper, as with the digital logic final exam.
Yeah, last subject also normally you're going to have part A, part B, and part B is you need to write and then you need to scan, you need to submit, right? That thing we can see and we can help student, especially let's say you need another 1 or 2 marks to get A maybe. So in kind of that question, maybe we can find any things that to help student to give extra marks. But I don't know what happened. They don't like that kind of way.
At least
But
the part B can be on pen and paper in the final at least.
maybe I will double check with them, and if let's say they still because last time I said I do believe with my student. I said I think they understand, but maybe they write the answer in wrong column. I said to them, and then they said what my student, some of them get 0. I was thinking, huh? So they just reply me, why I need to bother, because her student also getting bad, which is 0 in part B. So I was thinking, why you are answering like that? Because I was worried. So they said e-learning is the better. It's depend on the student, something like that, to answer it, because they already mention right how to answer. That's why they justify it's okay. Each of the column they put how to answer, right, how the format and so on. So maybe for final exam, I try to approach them again to marking by lecturer.
Okay.
So any other question? So please make sure you do many exercise for your module 3 and module 4 for your test 2. I really hope that you can increase your marks and yeah, you can beat your Perdana student, because normally we are labeling MJIT space student, they have quite low in so I hope that MJIT student also will show some things in the COA subject.
Inshallah, doctor. Inshallah.
Okay. So if there is no question, I will share with all of you another one more time your QR code, and if you already scan it, you might leave. Okay, thank you and have a good day. Selamat Hari Raya.
Thank you, Doctor.
Doctor, can you upload this lecture by today?
Okay, I need to stop first the recording. Okay. Once I